All right, so literal equations portion of our study guide. So y equals mx plus b, hopefully you have seen that plenty of times before, or at least rings a small bell. That is your slope-intercept form of a linear equation, which is something we are going to get into in our next unit again. And you will need to be able to manipulate this guy. And it does have more than one variable. So a lot of people just don't put together that this is a literal equation as well. They just put it in the linear unit and that's it. So a lot of students don't realize. So if I have this equation, I need to solve for x, as I did in our video last night, or today's video, sorry, when you got it, it was today. So your line of great divide, we need x by itself. So we box in our x. You want to first check if there's anything outside that box that can move, and you want to get it away. So you don't want to move things onto that side. And that's the reason for, like in this case, that big green line and red box. For a lot of people, it's the getting started process that's a little more difficult. So minus b on both sides. Y and b are not like terms, so I can't combine them. I can just write that I am now doing y minus b equals mx. In our video, like I said, is x by itself yet? It's not. It's attached to m, and it is attached to m by multiplication. And hopefully by now, if you watched enough videos, you've heard me say it 100 times. The inverse of multiplication is division. So we're going to divide by m. Divide by m. That's going to make these m's go away. And so now I have y minus b over m. There's no numbers, no variables that are the same. That's it. Done. It's your answer. It's ugly. It's hard for most people to even get remotely comfortable with that. But you stop there. So even though it says solve the literal equations for a variable, you're really not solving per se. You are just reordering. So you are getting that variable by itself, which is why they say solve. But sometimes it's easier to think about it as not going to be x equals a number. Like you're not going to get a solid answer that sits well with a number and then you're out. It's just making things go in a different order to be able to manipulate it the way you need it, especially like in this form when it's a function that you are going to use later. So y equals mx plus b again, but this time we're going to solve for b. So my great divide line, box in the variable that I'm solving for. It's a positive, so not too much of a conversation there. That mx is attached to b by addition. They are attached to each other by multiplication, but I want to move that whole thing at one time over by subtraction. So I'm going to subtract mx from both sides because it's a positive mx. And I'm just moving it into the other classroom or the other side of that line. Mx and y are not like terms again. And then I have b by itself because that got rid of that mx. You ask yourself, is b by itself? It is indeed. So we're done. Does anybody have a question about those two? I'm going to bet no. You guys are not talking to me. But maybe. That is a formula that you are going to manipulate and move things around in the next unit and for probably a lot of the rest of your mathematical career. So that one you do want to get very comfortable with, the y equals mx plus b, and being able to solve for m or solve for x or solve for b. Or if it's in a mixed up shape, you're going to need to solve for y. So if it's not in slope-intercept form but still a linear function, you are going to see that one a lot. So number 12 is perimeter. This is perimeter of a rectangle. So length times width. So like 2 times the length, 2 times the width added together, you get the perimeter, which is the length all the way around the outside of a rectangle. And sometimes they don't give you all the parts. So in this case, we're going to solve for w like it says. So I have my great divide, box in my w. Outside that w box, we have a 2L. That's at 2 times length. And that is attached by addition. So we're going to subtract 2L from both sides. That 2L cannot be combined with a capital P because they are different, not like terms. I'm trying to make my L's not look like ones. And ask yourself now, after that first step, one step at a time, is W by itself? It is not. It was attached to that 2 by multiplication. And the inverse of multiplication, again, is division. So we're going to divide both sides by 2. These go away. So W equals big P minus 2L over 2. You cannot reduce this guy because P minus 2L is attached by subtraction. So it's like a binomial. It's all one thing that's happening. So I can't cross out those 2's or do anything crazy to that guy since the 2's on the bottom as a single term. The 2 terms at the top attached by subtraction are untouchable when they're like that. It makes it called a binomial, and it's stuck the way it is. You can't start breaking them up that way. All right. 2PL plus 2W, solve for, and that's supposed to say L. I'll fix it. So solve for L. And I just wanted to show you again, it's really a lot of the same process over and over and over, which is what I said on our daily page. Oops, that was wrong. Getting too excited of repeating when I say it's repetitive. It's just a matter of working enough of these that the processes are exactly alike. It's just one, like I said, going slow enough, identifying what you're solving for, identifying what's on the side with it, what operation is it attached with, things like that. But ultimately, it's a repeat process over and over and over. So I'm going to subtract 2W because I want L by itself this time. So P minus 2W equals 2L. I need L by itself. L is still not by itself. It's attached to 2 by multiplication. So I'm going to divide. And then these 2's go away. So L is by itself. And it's P minus 2W all over 2. And those 2's again cannot cross out because P minus 2W is a binomial. All that operation is happening at one time. So that's it. We're done with that one. And again, that's perimeter of a rectangle, which again, if you don't see it in our class, you will deal with that for sure in future classes. Math 2 probably, and you did in the past already. Definitely in Math 3 when you start doing volume and all that fun stuff again. 14, so this is density. That is a Math 3 concept, and it's also in science. So density equals mass over volume. Density equals mass over volume. And you will solve this problem, again, actively in your future math classes for different variables. They will give you some but not the other. So being able to manipulate and move it around is the name of the game. So that's why we're learning this now. I want to solve for V. So this is a two-stepper. It's a mixed up, like we're in that fraction where a lot of people don't like and panic. Don't panic because that is M divided by V. And we have to get V out of the basement or denominator to get it by itself. And since it's division, which we should be getting really good at because I feel like I've said it 100 times in the last 3 days, the inverse is multiplication. So we're going to multiply both sides by V just to get it out of the denominator. And so now I have V times D equals M. The question is asking us to get V by itself. So you want to ask yourself, is V by itself right now? It is not. It is attached to D by multiplication because that's what we had to do to get it out of the denominator. So we're going to divide by D. And so now these D's go away. So volume equals mass over density. And you're done. Number 15, I think it's pretty easy, especially after these last ones. Solving for X. When it says X, most of us don't panic. That is 8 times X. And the inverse of multiplication is division. So we're going to divide both sides by 8. So I'm going to have U over 8 equals X. Is X by itself? Indeed it is. So you are good to go on that guy as well. Pretty simple on that one. Number 16 is one that I can remember in the classroom. Tons of people messed up. But again, if you go slow in your brain and you think, how is it attached? What am I getting by myself? And what operation am I doing? None of you, if I told you that I had apples, I don't know, it's kale, watermelon, and I don't know, V fruit, violets. We're going to have flowers. So you have apples, kale, watermelon, and violets. If I told you to put all the like things in one basket, you would ask me for 4 baskets with no question. But for some reason, when we start solving these equations like this, we want to start shoving things in make-believe places. So remember, none of those letters can be combined together in any way, shape, or form because they're as different as apples, kale, watermelon, and the flower violets. So they're all going to stay separate. At that rate, we need to figure out what we're solving for. So A, again, if you box it in, it seems so ridiculous, but if you trust me, it will get you started in the right direction so you don't do a lot of extra math to work around yourself. We need to move K. It is attached by addition, so we're going to subtract K from both sides. And then this is where most students are good, and then we panic, and they write all sorts of wild answers. So my suggestion, write exactly what was there before, and then ask yourself again, what did I do? I subtracted K, even though it's written under it, and that's why I use different colors, because sometimes if you just write in pencil, it all starts to run together, especially if you're nervous or don't feel confident. It's not divided by K, though. It is subtraction of K, because that is the inverse of addition. So it is simply minus K, because that's what I did, was subtract K. That is ugly and not fun for a lot of students for whatever reason, but that is it, and you are done. But definitely, I've seen this one spin into all kind of wild sorts of answers. So again, just be very careful and know that the variables don't mix. And then talk to yourself exactly the way I'm over talking as well, to know your operations and inverses of such. So number 18 is still the exact same thing that we've been doing on the previous from 10 all the way through 16, except it is written like an EOC question. So from the very beginning, I cannot tell you enough, all of this math you have done before. You are gaining new vocabulary and more complex ways for them to ask the same question. So just like 10 through 16, very simple. I gave you a formula and I told you which one to go solve for, or an equation and told you what letter to go solve for. 18 is doing the same thing with a lot of fluff. So depending on how strong you are at reading, how easily distracted you are, if you're anything like me, I'm a huge fan of highlighters to keep yourself straight. Write things down as much as possible. So the area of a triangle, that is definite fluff. A, fluff, can be calculated by using the formula, not fluff. Formula is not fluff. B is the base and H is the height. In this case, a little bit of fluffy. Rewrite the formula so it represents the base, not fluff. So represents the base. That means we want it to be B equals of a triangle in terms of the area and height. That wording for a lot of people is going to be very confusing. Represents is going to be a keyword you're going to see in some of these wordings, or solve for, or in terms of, except in terms of, that's just meaning using the A and the H. So represents the base for this equation, this word problem version of what we are doing is, like I said, very EOC-like, because the skill itself, by the time we get to the end of the semester, you should be able to read through some problems as well. So we know we're going to use our A equals 1/2 base times height. And we need to solve for B. So that is this guy. Now, you could rewrite this depending on who taught you this the very first time. Sometimes you see it like this, and that is exactly the same thing. And it depends on, in your brain, which one makes more sense to you. But both are fair, and it is just a typing difference, formatting difference, but exactly the same thing. Dividing by 2 is the same as multiplying by 1/2. If I handed you a dollar bill and I said, divide it by 2, how much money do you have? You would tell me 50 cents. If I said, what's half of a dollar bill? You again would be able to tell me 50 cents with no problem. But for some reason, when it applies to a algebra problem, it gets a little weird. So again, I'm going to say that one more time, and I would write it somewhere if you're taking notes. Dividing by 2 is the same as multiplying by 1/2. Just like dividing by 3 is the same as multiplying by 1/3. The sooner you can get that somewhere tucked away in your brain, the rest of your math career, it will just knock off one of those little things that gives us some hang-ups. So to get B by itself, we need to get 2 out of the denominator. So we're going to multiply by 2. Multiply by 2, because that turns that into a 1. Same if I multiplied 1/2 by 2, that becomes a 1. So then it gets it off of this side as well, no matter the formatting. So now I have 2A equals B times H. Is B by itself yet? It is not. It is attached to H. What operation is it attached to H with? That is B times H. That we've gotten in a habit of just saying 2x is a thing. We have to back up and know that it is 2 times x. So in this case, again, B times H. And the inverse of multiplication is division. So we're going to divide by h because we are trying to get b by itself. 2a and h are all different terms, so it was 2 times big A, and we just divided by h equals b. Now is b by itself? It is indeed, so we nailed it, and we're done. But so be prepared to get to this level where we are going to have to be able to read through some sentence structure to be able to do our literal equations. As far as our quiz, there will probably be like 1, but it is definitely a possibility for your EOC style questions for there to be more words around it. Your choice. Do we want to keep doing literal equations? Do you want me to do some word problems? Do you want me to do some basic equations that were on this page? Some really big equations? Because we also have like multi-step equations, and we have about a max of 6 minutes if you are on a tight line of schedule, or I don't mind working 2 or 3 more problems and going over a little bit if you are willing to hang. So literal or regular equations, guys? Beautiful. I'm going to do regular equations then because I've watched people mess these up, and you're here. There's no reason for you to mess them up if you're here for me to explain them to you. I'm going to start at 9 because it has the least, 9 and 7 have the least amount of distribution. And because we're running out of time, I'm going to probably do 6 and 9 till the end of class. So looking at this, your orders of operations, this is a multi-steps. This is a big bugger. As soon as you see a set of parentheses, you want to take care of that first. And that's that distribution that we did earlier in the week or earlier in the semester so far. So negative 5 times x is negative 5x. And then we have to do negative 5 times 7. And negative times a positive is a negative 35. Plus 2 equals negative 9 minus, I was typing too fast, minus 8x. We were supposed to have the same variable there. I was typing too quickly and people showed up. Sorry. Now, this probably is a fair game. It's ugly, but for EOC calculator inactive, probably looking pretty good depending on what happens to these numbers, that this could be an inactive question. So let's try it with no calculator. So we want to get all our x's on one side and our whole numbers on the other side. You want to clean up first, in my humble opinion, because if we look at this side, are there 2 things that I can put together to clean up this side? Most people find their mistakes when they're starting to cross those equal marks with not carrying negatives appropriately or moving them as is. So the less you can cross the line for most students, the better they're going to do. So that negative 35 and positive 2 can be combined to give me that negative 33. So negative 5x, we haven't touched it. I owed you $35. I paid you 2. So I still owe you 33 equals negative 9 minus 8x. You can decide which side is your variable side. I usually work towards the largest variable number with the largest coefficient, because it'll get rid of my negatives. So negative 5 is actually larger than negative 8. If I move this 8 over, it's a negative. So I'm going to add 8. So that means I'll be working with a positive in front of my variable, which for most people is a little easier because we don't like negatives for some reason, most people. And I'm breaking this down super slow. Some of you can do multiple steps at one time, but I want you to see where everything's coming from. So now we need to get that 3x by itself. That's a negative 33 or minus 33 here. So we're going to add 33 to get that constant over there with our other constant. So 3x equals 33 minus 9. So $33, and then you spent 9. I take 3 away. That gets me down to 30. Take away 6. It's going to get you down to 24. And then divide by 3. So x equals, and if you're not sure, hopefully you know some set of your 3's multiplication tables. 3 times 7 is my favorite one to always kind of gauge by because that's 21, and I don't know why that one sticks in my head. And that's going to give you 21, so I have one more 3 left, so it's going to be 8. So x equals 8 on that one. Done. And of course you can plug it back in if you want and see if it works out to check it, and that would just be cleaning up and combining like terms again. So I'm going to quickly do number 6 because I see people dropping out of class already. So I don't want to bore you. So number 6, again, you're going to have a distribution. Your biggest thing is making sure that -2 goes through as a -2, that -2. But 5 times x is going to give me 5x. 5 times a -3 is going to give me a -15. This is like a wall. It stops that distribution of that 5. So now we're looking at that -2, and that -2 or -2 means that negative is going to go all the way through. So -2 times x is a -2x. -2 times 1 is going to be a -2 equals 4. So again, look at each side and see if you can clean up anything, combine like terms. So like our x's and our x's versus our constants and constants. If there's multiple on one side, condense, clean up first. So if I have 5x and I spend $2 because that's a -2, then I'm going to have 3x. If I owe you 15 because that's minus, and then I borrow because that's minus, borrow 2, so -5, minus 15, I'm sorry, and -2, and -17 equals 4. Now I have my variable. I want to get it by itself because we're solving for x. I'm going to add 17 to both sides. And that's going to leave me that 3x on this side. And 4 plus 17 is going to give me 21. Not done because x is not by itself. That is 3 times x, and the inverse operation of 3 times x, again, is divide by 3. And coincidentally, not prepared, didn't realize that one was going to work out that way. 21 divided by 3, as we talked about last problem, is 7. I've said it 100 times in lots of our videos and since we've been doing equations since the very beginning. Your biggest kicker on this is going to be to slow down, write things down, and stay neat. Don't write like chickens with your left foot. Because that's where you're going to mess up and lose negatives. Use colored pens, use colored highlighters, use the things to keep yourself straight. All right, guys, so that's a portion of our study guide for now on answers. Does anybody have any major pressing questions? I only went 1 minute over.